Hello students, good morning everybody. Hope all you people are safe. At the same time you people are enjoying your holidays. Yes, you people are enjoying a lot, but this is the time to bring your attention towards your academics also. This is the first class I am going to take for this academic year. Today I am going to deal with one of the chemistry chapter, which is the first chapter in your science textbook, unit number 1, that is chemical reactions and equations. Let's go to the topic. Yes, students, due to I don't have any blackboard, due to that reason I made some arrangement with the help of these papers. Hope definitely this will help you. Yes, our topic is chemical reactions and equations. Before enter into this chapter, I just want to give, we have to have some previous knowledge, some basic knowledge, what you learned in your 8th and 9th standard. Without this knowledge, it is very tough to understand this chapter. Okay, so just in this class, now I will give a quick recap regarding those ones. These are very, very important, okay, terms, scientific terms, and you have to learn at the same time, you have to remember these scientific terms and their definitions also. Okay, first one, matter, we know very well. Okay, whole universe, whether it is a living thing or non-living thing, we call it as a matter. Okay, anything which occupies some space at the same time, which has some volume, we consider that one as a matter. Okay, so next one is the second one is the atom. We know very well. Okay, according to the Dalton's atomic theory, what it is means, all matter is made up of a small particles called atoms. Atoms are very, very small. We can't imagine the size of an atom. Then atom is unable to exist independently. We know about this one also. Third one is the molecule. Yes, already we know that one, atoms are unable to exist independently. What will happen means two or more than two atoms of same type or different types will combine and forms molecules. If the atoms of same type, means same type of atoms, two or more than two atoms combine and forms a molecule, then it is called molecule of an element. Okay, example, H2, hydrogen gas, we know very well. Here, two hydrogen atoms, means both the atoms are same types, can combine and forms the molecule. Next one is the molecule of a compound, means if the atoms of different types, means not the same type of atoms, will combine and form a molecule, then we consider that one as a molecule of a compound. Here it is the example I have taken, H2O. We know here two hydrogen atoms and one oxygen atom combine chemically. They form bond, okay, and forms water molecule. Okay, this molecule means simply what we can say, it is, a molecule is the smallest particle, okay, of an element or a compound that is capable of an independent existence and shows all the properties of substance. Okay, whether it is any substance. For example, water molecule, if you have taken, means a water molecule will show all the properties of, whether it is physical property or chemical property of water. Okay, this one, about this one. Next one is the symbols of elements. We know in your 9th standard textbook, page number 34, there is a table. Must and should please go through with that one. There they have given different names of different types of elements at the same time. Symbols also, means every time it is very tough write the name completely, carbon, CAR, it is very tough. So simply by using one symbol, we will write C, nitrogen for N, oxygen for O, hydrogen for H, helium, argon, like this. Okay, next one is the atomicity. Atomicity means, we know very well, the number of atoms, how many number of atoms that each molecule of a substance has is called atomicity of a substance, of that particular substance. Means we know very well atoms can't able to exist independently, but some of means what they will do to attain stability, they will combine and forms molecules. How many number of atoms are present in that particular molecule indicates the atomicity of that particular molecule. Some of the atoms are there which can able to exist independently. Those are called monoatomic. Okay, carbon, helium, sodium. At the same time, some more are there. Neon, argon, krypton, xenon. Almost all noble gases are monoatomic. Next one is the diatomic. Here two atoms will combine and forms. Means here number of atoms. The suffix what we have written after the symbol of element, it indicates number of elements. Number of atoms participated. Okay, here H2 indicates two atoms of hydrogen combine and forms H2 molecule. Okay, here also oxygen, two oxygen atoms combined and forms oxygen molecule. Then we consider that one as diatomic. Polyatomic, triatomic are there. Okay, triatomic example for the triatomic is O3, ozone. Okay, next one is polyatomic. Here 3 or more than 3. Okay, atoms combine and forms a molecule, then it is considered as polyatomic. Best example, phosphorus and sulfur. Okay, next one is one more important one. We have to learn, at the same time we have to remember, must and should to write a chemical equation it requires. It is very, very important, like symbols only. This one also. Names and symbols of ions. Okay, ion means an atom or a molecule that has positive or negative charge on it. It is called ion. Anything, an atom, for example, hydrogen, simple hydrogen atom. When it is H plus, means then it is considered as hydrogen ion. Okay, why we are considering, means here positive charge is there, means an atom otherwise or a molecule. Here we can consider this one as a molecule. Okay, an atom or a molecule that has positive or negative charge, with a positive or negative charge, then it is called as ion. We have two types of ions, that is cation and anion, based upon the which type of charge it has. If it has positive charge, then it is called cation. If it has negative charge, then it is called anion. Okay, in your page number 37 also, last year means 9th standard textbook, there is some ions names, at the same time symbols. Must and should go through with that one. Okay, next one is the chemical formula. How to write a chemical formula. Whenever you are writing, means it is must and should to learn how to write a chemical formula. I have given some of the names, name of a chemical compounds here. Then you have to write the chemical formula for these ones. Okay, aluminum oxide, sodium carbonate, sodium bicarbonate. Try it, definitely you can do it. Just I will show one example how to do also. For example, nitric acid. If you know ions, symbols of ions, then it is easy to write down a chemical formula. For example, I have taken nitric acid. Here nitric acid is formed by the hydrogen and ion and nitrite. Hydrogen ion, hydrogen is H plus, at the same time nitrite is NO3 minus. Okay, just you have write like this, H plus and NO3 minus. The charges on this one is also only plus indicates, means only one. So I have written 1 on the down, the charge which it has. NO3 minus means it indicates it is also has the charge of only 1. Crisscross it, then what will happen means 1 we no need to write H1 NO3 1, not necessary. So we are simply writing the formula as HNO3. In the same way you can practice these ones also. Definitely you can do it. Aluminum oxide, sodium carbonate, sodium bicarbonate, for these ones also. Okay, next, these are all very important. You have to learn these ones and you have to remember also. Now still we are in just in recap section only. Matter once we started our topic with matter, matter has its own physical properties and chemical properties. Yes, it's true. Every matter has its own physical properties at the same time chemical properties. Means, for example, some matters are if it is a solid state, liquid state, or gaseous state. That is the physical property what we can see. Okay, at the same time, even though physical properties are same, also sometimes their chemical properties are different as one to another. Okay, just I am giving one recap what we learned in last year. Matter is made up of small particles. You know about that one. Particles have space between them. They continuously move. At the same time, they attract with each other. These are all responsible. Means these characteristics of the particles are responsible for the different types of physical as well as the chemical properties of the matter. Okay, we learned last year also states of matter. At the same time, we can interchange states of matter from one to another by increasing or decreasing temperature, by increasing or decreasing pressure also. We know about that one. The best example, our water ice. It is in solid state, it is in the ice form. When you increase the temperature by supplying heat, it is converted into water, that is the liquid form. Again, further increasing temperature, it is converted into gas form, that is the water vapor. At the same time, when you decreases the temperature, again we can begins condensation. We can bring it back into liquid state. At the same time, further decrease in the temperature, what will happen? We can convert the liquid state to further cooling effect. We can convert it into solid state also. At the same time, by using the pressure also, by increasing pressure, gases are converted into liquids. We know about this one. The best example is our LPG gas which we are using, or liquid petroleum gas. But it is a gas. What will happen? Due to increasing pressure, it is converted into liquid state. It will be stored in our cylinder in the liquid state. Okay, this is the thing which we learned. Here, why I am going to explain these are all means, if you will observe, these are all the physical changes. Converting ice to water, water to water vapor, and converting back water vapor to water, water to ice. These are all, we consider these ones as a physical change. We cannot consider this one as a chemical change. Okay. At the same time, one more process is there, sublimation. We learnt about this one is also here. Solid is directly converted into gaseous state without undergoing liquid state. From gaseous state to again matter is converting into solid state. We can convert into solid state without undergoing liquid state. Okay, we learnt about the evaporation process also. This is also one physical property, physical change. Okay. Due to that reason, I have given, means what is the difference between the physical change and the chemical change, you have to learn. Now, physical change, what I explained earlier, the same one, ice, converting ice to water, water to water vapor. Means which change we consider as physical change. Okay, means some of the properties we consider, means some of the changes we consider as physical changes. At the same time, some of the changes we consider as chemical changes. Which changes we consider as a physical change? Now we are going to discuss. Means in physical change, what will happen means no new substance is formed. The same substance, means for example, ice to water, water to water vapor. If you try to take some amount of ice in a container, otherwise in a vessel, just supply heat. Okay, check the temperature at which time it will convert to, leave about the water stage. It will, whenever you will supply heat from ice to, it will convert into water, water to water vapor. Whenever it starts boiling, the temperature generally what will happen? At 100 degrees Celsius only, it is converted into vapor state. Same, if you take some water instead of ice, then also you supply, supply some heat. That time also what will happen? At 100 degrees Celsius only water is converted into water vapor. Means here there is no change in the composition of water. Due to that reason, means we are seeing some change in the state. Okay, we are changing from solid state to liquid state to gas state, but there is no change in the composition. At the same time, we are seeing only the change of state. Here any new substance is not formed. Okay, this change is temporary change. Yes, whenever you decrease the temperature, again water vapor is converted into water, water is converted into ice. So we consider this one as it is a temporary change. No new substance is formed in physical changes. At the same time, it is reversible change. Yes, we can convert to ice to water, again water to ice by freezing. Is it correct? Yes, these are the characteristics of physical change. Now, our original topic, we are going to start, which is useful for us, means for this academic year, chemical change, which we consider as a chemical change. By this time, we discussed about the conversion of ice to water, water to water vapor. Now, just take some amount of, you can do at home also. Just 3 to 4 tablespoons of sugar you take in a pan. Just supply heat. Okay, put it on the stove or something. Okay, then what will happen means, after some time, means it absorbs heat and the sugar crystals will start melting. After some time, what will happen means, sugar is converts into caramel. Okay, sugar converts into caramel. Okay, here what happened means, the sugar which is converted into caramel, is it possible to make to change caramel back to sugar? No, it's not possible. Means the change, whatever may be happen, it is a permanent change. It is a permanent change. It is an irreversible change. It is not a temporary change. At the same time, it's not a reversible change. It is an irreversible change. Okay, here why it is a permanent change, why it is a irreversible change means, there is a change in composition. Okay, sugar, whatever may be the molecules of sugar, which is the structure completely get altered and a new substance is formed. New substance is formed. Due to that reason, it is a permanent change, it is irreversible. Here, like physical change, in chemical change also, we can observe change of state. We can observe change of state. Simply by seeing change of state only, we cannot say the change, whatever may be happened, is a chemical change. But when we consider a change is a chemical change. Change where there is a change in the physical as well as the chemical properties are called chemical change. Okay, change where it takes place, where there is a change in the physical as well as the chemical properties are called chemical change. Whenever chemical change has taken place, we consider that one as a chemical reaction. We consider chemical change as chemical reaction. Okay, this is our original topic we have to learn in this academic year. Yes, for example, there is one more topic is there, how to recognize a chemical change. How to recognize a chemical change. The best example just now I have given, that is converting sugar to caramel. You can do it at home. That's why I have given this example. Just see that one. Whenever in this process, whenever you are trying to, means whenever you are supplying heat to the sugar, what will happen means, you can see change in physical state. Yes, solid crystal state to it is converted to semi-liquid state. At the same time, prominently you can see the change in color. Yes, earlier the sugar, if it is white sugar means white, if it is brown means brown sugar. But what will happen once it is converted into caramel, the color of that liquid, it is dark brown only. Okay, Yes, we cannot see evaluation of gas in this process. In some other chemical reactions we can see, but change in yes, this one is also we can't able to observe in this one. But sometimes one more is we can find some characteristic order, means some different. It is not the like the normal one. Some characteristic order also we can observe based upon these ones, means these are the signs of a chemical change. I mean, whenever the chemical reaction takes place, we can observe one or more than one. Even all these are all also we can observe sometimes. Okay. Yes, in this class, just I have given some of means some quick recap what you learned in your last year. At the same time, what is chemical change? In the next class, how to write a chemical equation. At the same time, how to balance a chemical equation. Okay, we will meet in the next class. Just I want to give some homework. It is very simple one. What it is means, please all of you maintain your classwork. After writing the title of the lesson, must and should, please write down. These are all means what is math. I have given some scientific terms and the definitions. Must and should. You can refer your last year classwork book. Otherwise, your textbook also. Some of the tables are also in page number 34, 36, 37. Must and should you have to copy, and then afterwards please learn, go through with this one. If you have this basic knowledge, then only very easy to understand next class. Thank you.